Guys, all right, so we're in week 2 of distance learning, and I've done it just a little different than last week. I'm not changing anything with how I'm going to do the videos and the practice problems, but I have attached the notes that I write on this program on my computer, so that if you have access to a printer at home, you can print those notes off and copy them straight onto that sheet of paper. Now, if you don't have access to a printer at home, that's fine. You'll just do the exact same way that you've been doing it. But a few people asked me if they could have the notes that I was using, and so I went ahead and sent those notes to them. So I'm just going to attach them so anyone who has access to a printer, your parents can print it at work on Monday, and you can do it however you want to do it. Now, again, if you don't, just do it like you did before. Okay, so this week we are going to be talking about rational exponents. And I thought before we got into how to solve for rational exponents, we need to be reminded about what a rational number is. And so I wrote that definition over here. So a rational number is a number that can be made by dividing two whole numbers, basically a fraction. So an example of a rational number would be just like you can take this decimal and it can be changed into a fraction. Or you could take 0.3 repeating, and that's 1/3. Okay, so those are rational numbers because they can be simplified into a fraction. Now, a non-example of a rational number would be like the number pi. Okay, that's pretty much the last thing we talked about before school was out. It's 3.14159, and it goes on and on and on and on forever. And basically, you can't write that as a fraction. So that would not be a rational number. Okay, so we're going to be looking at how those numbers will be used as exponents. Okay, so what we learned last week were just the rules for when you're multiplying and dividing those integer numbers. An integer is a whole number: 0, 1, 2, 3, 4, 5, -1, -2, -2, 3, and so on. Okay, so now we're going to be looking at the rule for when you are doing it to taking an exponent of a rational number. Basically, the exponent is going to be a fraction. Okay, so that's all it means. So when you are looking at a number that has a fractional exponent, you may be wondering, how do you get rational exponents? Well, rational exponents come from square roots. Okay, and it can be also come from cubed roots, fourth roots, fifth roots, sixth roots, and so on. Okay, this one right here, it doesn't have a number, but it's squared. If there's nothing there, it's understood to be 2. All right, so that's how you get a rational exponent. So I'm going to show you how you go from a square root or a cubed root, which is the 3, or fourth root, or fifth, or sixth root, and it ends up being a rational exponent. So if you're looking at it, it's to the whatever number you're dealing with, this number right here, whatever your root is, that is going to end up becoming your denominator of your fractional exponent. Okay? Did I spell that right? I don't know. All right, so let's go ahead and just start looking at some of the examples, and we can see if that starts making sense. All right, so we're going to be taking the square root of some number. So I'm going to choose the number 49. So we're going to take the square root of 49. All right, now just to be clear, I know we've kind of touched on what a square root is, but when you think of a square root, if it's the square root. Can't write. Okay, You can't see that. Square root. All right, when we're taking the square root of a number, see this number 2? Whoops, kind of marked it out. But the number 2, basically you're wanting to see what two numbers that are exactly the same you can multiply together to get you 49. Okay? If you were taking the square root of 25, you want to see what two numbers you multiply together to get 25. Okay? That's all a square root is. Okay? Now, this is going to become, so this is my root right here, just like it says up here in the example. Whatever number is on the outside of that root is, or this outside of the square root is my root, okay? And that's going to become the denominator of my fractional exponent, okay? So we keep the same base, so it's 49, and then it's going to be 1 over 2. So 49 to the 1/2 exponent, okay? So either way you look at it, if you see 49 raised to the 1/2 exponent, or that's the same thing as the square root of 49. They are the same thing as each other. They are equal. They're the same thing. That's just showing you where it comes from, okay? So either way you look at it, that's what it's asking. So if you see the square root of 49 or you see 49 to the 1/2, it's wanting to know the two things you multiplied to get 49, which is 7. Okay? Now, if you have access to a calculator at home, or you've downloaded that app that I told you about, the TI-84 calculator app, which I highly recommend, you can also just type it directly into your calculator. Now, just like I've told you with exponents before, you have to be careful how you type them into your calculator. So if I did 49 raised, now if I want to type in 1/2, it has to be in parentheses. So you have to put that little parenthesis 1 divided by 2, and that gives you 7. Okay. There's also an option for square roots, but we'll get into those in a minute. Okay. So let's go back to your notes and keep working through some of these. Okay. So now we're going to look through this cubed root. Okay. So that's our root, and now we're going to do it for the number 64. So we're taking the cubed root of 64. Now the only difference between a square root and a cubed root, a square root you wanted to see which two numbers that were exactly the same that you multiply to get 49. A cubed root, you want to see what three numbers that are exactly the same that you multiply together to get you 64. Okay, so again, whatever our root is, that's going to become our denominator of our fraction. Okay, so that's going to be 64 to the 1/3 exponent. Okay, so what three numbers can we multiply together to get 64? That's going to be 4. Now again, you have access to a calculator, use it. Next, fourth root. Fourth root of 81. All right, square root, what two numbers? Cubed root, what three numbers? Fourth root, what four numbers will you multiply together to get 81? Okay, so whatever this number is here, again, is going to be our denominator of our fractional exponent. So 81 to the 1/4 power is essentially the same exact thing as the fourth root of 81. What four numbers do you multiply together to get 81? And your answer is 3. Okay, and again, if you wanted to use your calculator, you could say 81 raised to the 1 divided by 4 is 3. Okay, now you can't really do this on your calculator on your phone, so that's why I highly recommend downloading the TI-84 calculator app. It's free, okay, and you can do all of these same things, and it will look identical to this one I have on my screen. Okay, next one. So we have the fifth root. Okay, so you can see all these little examples here that root is just going to become the denominator of the base, the rational exponent base. Okay, so this one we're going to do it of 32. Root of 32. All right, so that's going to be 32 to the 1/5 power. So what can I multiply? What same number can I multiply 5 times? Wow, I really struggled to get that out. Will equal 32, and that is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so again, that's how I'm getting that number. All right, last one, the 6th root. So we're going to take the 6th root of 64. Okay, so what number can I multiply by itself 6 times to get 64? So that's going to be 64 to the 1/6 exponent, and that number is 2. 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Okay, so that is how you do rational exponents when it's just simple fractions. Okay, now down here, we're going to go just one step further. So I need y'all to stay with me. Okay. Now, what we're looking at here is we have same situation. We have a number raised to, or we have a number and we're taking some root of it, squared, third, fourth, fifth root of it. Okay. Okay, then we're taking that entire thing and we're taking it to a power. Okay, so when we rewrite this, what's yellow becomes a fraction, just like we just talked about, but then we have to go and take it to another exponent. Okay, so if we use the rules of exponents like we talked about in last week's lesson, when you have something being multiplied inside of a parentheses and it's being taken to an exponent, what do you do with your exponents? You multiply them. Okay, so that's m over 1. So that's going to be m times 1 is m. 1 times n is n. Okay, so this is going to be what you have. All right, so again, your root is going to be the denominator, just like in the last one, and then whatever your power is being raised to, that will be your numerator. Okay, that's a lot of information. So let's look at some problems and we will discuss them. Okay, so let's start with purple again, just because it's pretty. Okay, so we're taking the square root. So remember, if there's not a number with your little square root or this little root symbol over here, it's understood to be 2. Okay, so the square root of some number cubed. Okay, so basically that's the same thing as taking the number that you're taking the square root of and raising it to the 3/2 power. Okay, so let me show you how that works. Okay, so here is our squared, that's our root. Here is our power. So every single time you do it, your base stays the same. Ooh, that's large. Your base stays the same. The number of your root is your denominator. And then the number of your exponent is your numerator. Okay, so let's look at it with an actual number. We are going to take the square root of 9. Square root of 9 to the third power. Okay, so the easiest way I can tell you to do this, so we know that this number of the root is going to be our denominator, and the power is going to be here. Okay, so a lot of you may be wondering, how am I supposed to solve this without a calculator? Well, I would just follow order of operations. Okay, so first thing you need to do, first step, I would do what's inside of my parentheses. How about I use a different highlighter? Okay, I'm going to do what's inside my parentheses first. So I'm going to take the square root of 9. So what two numbers can we multiply by itself to equal 9? It would be 3. Step 1 done. Now we know that all of this right here equals 3, and we're going to take that to the third power. So step 2, we're going to do to the third power. Okay? So that's going to be 3 to the third power. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay, so that would equal 27. All right, and again, you can always check it on your calculator. If you wanted to do 9 raised to the 3 divided by 2. 27. All right, if you're wondering how you do a square root on here, you go to math, and then right here at number 4, there's a cubed root. But right here on number 5, there's an X and then a root symbol, so you can just go down to 5, hit enter, and then it leaves it blank for you to type in what root you want to take it to. So you can take the square root and then just arrow over to 9, and that equals 3. And then you can take 3 and just raise it to the third power, and that equals 27. Okay, so all of that you can do on your calculator if you wanted to. All right, so let's look at another one. I'm going to kind of box this off so we can try to stay organized. All right, so let's look at this one. Now we're going to do the exact same thing. We're going to take it to the cubed root and then square it. Okay, so basically it's just like the last one, the numbers are just backwards. Okay, so we remember the root is always going to be the denominator, and the exponent will be the numerator. Okay, I don't know if y'all can see that, but that says denom and num. Okay, so let's do it for the number 64. So I have the cubed root, 64, and I'm going to square it. Okay, now, since you may not have access to a calculator at home, well, I'm getting ahead of myself. So let's rewrite this as a rational exponent. So we know the root is going to be our denominator, so I'll keep the same base of 64. 3 is going to be my denominator, 2 is going to be my numerator. Okay, now, how do we solve this if we don't have a calculator? Okay, so step 1, we follow order of operations. Okay, so I do what's inside of the parentheses first. So I have cubed root 64. What times what gives me 64? Sorry, I was looking at the wrong one. It's 4. Okay. Yeah. Okay. So once we do that, step 2 is we have to do it to its exponent. All right. So I'm just going to go 4 to the second power, which is 16. All right. Now, eventually, this step right here, it's just going to come easier because they're going to give you numbers that are going to come out even. Now, eventually, you'll get to numbers that are not going to come out to perfectly whole numbers like this, but we'll get to that later. Okay, just right now, know that it's all of these that we're going to deal with today are all going to come out to nice whole numbers. All right, next, the cubed root raised to the 4th power. Okay, so again, whatever the root is going to be your denominator, and whatever your exponent is going to be your numerator. Okay, so we're going to do it for 8. So the cubed root of 8 to the 4th power. So it's going to be 8 to the 4/3 power. Okay, so All right, so step 1, do what's inside the parentheses first. So we have the cubed root of 8. What times what times what equals 8? It's 2. All right, and then we're going to take 2 and we're going to take it to the 4th power, which is 2 times 2 is 2, times 2 is 8, times 2 is 16. Yes, checking my notes. So I don't want to tell y'all wrong. All right, so that's your final answer for that one. All right, so you can kind of see a pattern as we continue going. All right, next, the 4th root of b to the 3rd power, okay? So we know our root's going to be our denominator of our exponent, and our exponent is going to be our numerator of our rational exponents. Okay, so we're going to do it for 16. So we're taking the 4th root, okay, that works, of 16 to the 3rd power. Okay, so our root's going to be our denominator. So 16 to the 3/4 power. Okay, so how do we solve this without a calculator? Step 1. Step 1, the 4th root of 16. What times what times what? What times what times what times what equals 16? It's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, then we take that number and we take it to the exponent 3. So 2 to the 3rd power, and that equals 8. All right, and it makes sense that our final answers that we're getting up here are small, are when we have a, never mind, just forget that statement, it's just going to be confusing. All right, last one. We have the 5th root of b to the 2nd power. Okay, so we're going to take, so we know that the root is going to be our denominator, and our exponent is going to be our numerator. Okay, which they already have here for us, but we're going to do it for 32. 5th root 2, and we're going to do all that squared. Okay, so our root is our denominator, so that's 32 to the 2/5 power. All right, last one. How do we solve it if we don't have a calculator at home? Step 1, do what's inside the parentheses first. Okay, we have the 5th root of 32 is 2. Now, again, if you do have access to a calculator at home, you can easily do this. Math, go down to 5. The 5th root, arrow over, to 32, and that equals 2. Then you can raise it, what was it, to the 2nd power, and you get 4. Okay, if you have access to a calculator, it does help a little bit. So then we're going to take 2, and we're going to do it to the 2nd power, which is 4. And that is how you do rational exponents. All right, so, and they all stem from, square roots. That's how you do. All right, I'll have the next video for us to go over all the practice problems.